Am I audible? Okay. Thank you very much. So let us start with the next task, which is 2.4. 2.4 is configuring SD-WAN VPN route leaking. Okay. So here route leaking. Route leaking is nothing but uh, uh, redistribution, but between two VPNs. Okay. To allow the traditional parts of FABD2 network to communicate with the employees and IoT VNs, configure route leaking in SD-WAN according to these requirements. Prefixes in IoT VPN 198 must be imported into existing SD underlay VPN 999 and tagged with a value of 198. So there is a VPN 198 which should be imported into 999 and it should be having a tag value of 198. Prefixes in employee VPN 200 must be imported into existing SD underlay VPN 999 and tagged with a tag value of 200. So there is a VPN 200 which should be imported into 999 and it should be having a tag value of 200. Prefixes in SD underlay VPN 999 advertised from DC that are within 10400/15 range must be rejected. Other prefixes in SDA VPN 999 underlay VPN 999 advertised from DC must be accepted and also imported into IoT and employees VPN. So instead of this subnet 10400, every other subnet should be advertised into 198 and 200. There is no tag over here. Redistribution from OMP into OSPF on branch 1 and branch 2 in VPN 999 must exclude the routes tagged with a value of 198 or 200. Place host 41 into employees VN and 51 into IoT VN. Make sure both hosts receive their IP settings from DHCP server. Ensure that the IoT and employee VPNs on branch 1 and branch 2 have reachability to the branches 3 and 4. It is allowed to modify the VPN 999 OMP setting to accomplish this requirement. So let us go under vManage. Now this time under vManage, we need to go under policies. So we will go under configuration, policies, and here under policy, I'll create a custom options and I'll create a route policy, add a route policy, create new. Now I will first start with this point, redistribution from OMP into OSPF on branches 1 and 2 in VPN 999 must exclude routes tagged with a value of 198 or 200. So I'll say route policy. I'll keep this name saved somewhere. I will be using this name in the future. So I'll say sequence type, sequence rule, anything coming with the OMP tag of 198, reject it, save. Second rule, anything coming with the OMP tag of 200, reject it. Okay, reject these two, then go to, whenever you are having a reject rule, you have to go under default action, edit this and say accept all the others, save. Okay, so this is my route policy I have created. Now save this policy. Now you have saved this policy. Now go to templates. Now first go under device template branch 1, edit, go to additional templates. Sorry, under policy itself, you need to go under localized policy, add a policy, next, 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 add a route policy, import existing, and here select the route policy, import. Then next, and here this you will create a local policy. So I'm just giving a name as local, save policy. Now go under templates, under device template, go under branch 1. Under additional templates, you will see policy over here, select local policy, update. Next, configure. Wait for the success message. Now same, go to policies, sorry, go to templates, do for branch 2 as well. Edit, go to additional templates, local policy, update. Next, configure both the devices. Okay. Okay. Now again go to templates. This time go to feature templates and search OSPF. You will see branch 1 OSPF VPN 999 template. Edit this. Go to redistribution under OMP. Edit this OMP redistribution. Go to global and paste the name of the route policy which we have created. Route. You have to paste the name as it is. Save. Update. Next. Configure. Same thing you have to do for branch 2 as well. Go to templates, feature templates, OSPF, branch 2 you can see over here. Edit. Go to OMP redistribution, edit, global, paste the name of the policy, save changes, update. Next, configure both the devices. Okay. Okay. Now again go to policy. Now before creating the policy, I'll create some list. So go to custom option, under list, under VPN, add a VPN list. First is VPN 198, which has ID as 198. Then we have VPN 200. Then we have a VPN 999. Then we have a VPN list, which will include 198 and 200 both. 198, 200. Then we will have, okay, VPN is this much only. Then we will have some site list. One site will be DC 65002, and one site list will be all sites. All sites will include DC, branch 1, branch 2. then there will be a prefix list which will be already pre-configured with this subnet as reject. Okay, but here on our rack it is not configured, so I will create and I will show you how it will be pre-configured. 10.4.0.0/16 less than equal to 32, comma 10.5.0.0/16 less than equal to 32. This is how the prefix list would be created. Ten dot four dot zero slash 16 less than equal to 32. 10.5.0.0/16 less than equal to 32. Okay, these two subnets would be there. Now you will go under custom options and you will go under topology. Add a topology, custom control. And here you can give any name. I'll say custom. You can give any name. Now I will say route policy. First I'll create a reject route policy. I'll say anything coming from site DC under VPN 999, add a prefix list and reject it. So what we are saying anything coming from DC under VPN 999 which are in this range, reject them. Okay, this is one policy. Second one, to accept all these. We'll say anything coming from site DC under VPN 999 actions, accept it and export it to 198 and 200. Third rule, anything coming from VPN 198 actions, accept it, export it to 999 and add a OMP tag of 198. Again, anything coming from VPN 200 actions, accept it, export it to 999 and add OMP tag of 200. Save. These are the 4 rules that we'll be creating. As I said, if you have any reject rule, what you need to do, you need to go under default actions and you need to say accept. Then save the control policy. Then go to centralized policy. Just give me a second, guys. Guys, give me a minute. I'll just give me a minute, okay? Okay. So now you have to go to centralized policy, then add a policy. Next, add a topology, import existing, custom control, select the policy, import. Okay. Now next. Now here this is your centralized policy. So I'll give it a name as central. New site list. I'll add all sites in the inbound direction. I'll apply this policy in the inbound direction of all sites. Save policy. Now I'll try to activate this policy. Now it is giving me an error. vSmart are not in vManage mode. So this will be same in the exam also. So what you need to do? You need to go under devices, controllers, vSmart, running configuration, copy the complete output of the running configuration. Then go to templates. Under device template, create from CLI template, select vSmart. Then here vSmart and paste the configuration over here. Paste whatever you have copied and you have to add these two lines. Okay, where you have to add these two lines under OMP over here. Under OMP, you have to add these two lines and then add. Now you have to add a vSmart. So you need to say attach a device, vSmart, attach, configure, success. Now you need to go under templates, under feature templates, and you need to search VPN 999. Here you will see this VPN 999 SDA underlay VPN. Okay, edit this. Under advertise OMP, turn on OSPF external and update. Next, configure all the 5 devices, all the 5 VHS. Okay, now you can go under policies and now you can activate the policy. Now it will allow you to activate the policy. Now once the policy is activated, if you go under VH40 and if you see over here, so IP route VPN 198, you will see all the networks over here. And if you see show IP route, VPN 200. Here also you will see all the networks. Now, if you go on any of the VH in DC, suppose if I go on this VH, and if you see over here, show IP route VPN 999. Here you will see all the branches, network, okay, 198 and 200. Just give me a second. I think just give me a minute, guys. I think I made a mistake over here somewhere. If I take any network of 10.4, and if I see show MP routes, detail, here you will see this is a VPN, this is an entry for VPN 999. It is coming from vSmart. Originator is VH40 and it is tagged with a value of 198. So that means this is a route of 198. Okay. If you go on any of the switches over here, suppose if I am on switch 400 and if I see show IP route VPN 198, sorry, let me go on 500, 501, show IP route VRF IoT. Now under IoT, you will not see employees VPN 10200, 10, 104 200 or 105 200. But these networks are very important. These are my branch 3 and 4 networks and my tunnel IPs. And if you see in employees, you should not get the 104 198 or 105 198. But again, these networks are very important. Okay, now from here I can ping any of the branch 3 IP, ping under VRF IoT 10.6.100.101. I don't know if they have an IP address or not. IP DHCP. Okay, I'll try to ping again. See, I'm able to reach branch 3 from IoT VPN, IoT VN, you can say. Employees also will be able to reach. I'm able to reach ping under VRF IoT to 8.8.8.8. Think the ISP interfaces are down. I'll just make them up. As I said, this is something a rack issue. Okay, now it will form the neighborship with R24 and should be reachable there. Okay, same thing for employees. Okay, guys, this was your task 2.4. A lengthy task, but need a practice. 2.5 is handling guest traffic. The guest VPN on branches 1 and 2 must remain isolated from the rest of the company network. It is only allowed to reach internet through R23 and R24 in the DC. Enable internet connectivity for the guest VPN according to these requirements. On VH21 and 22, place the gig 0/2 GE 0/2 interfaces into the guest VPN 199. On R23 and R24, create a new VRF named guest using the RD value 65002:199 and place the gig 4 interfaces into this VRF. Assign addresses to these interfaces. On R23 gig 4 10.2.123.1/24, R24 gig 4 10.2.224.1, VH21 GE 0/2 10.2.123.2 and 22 this IP address. Peer R23 and VH21 in the guest VRF VPN using iBGP. Peer R24 and VH22 in the guest VRF VPN using iBGP. Now, if you remember, we have configured iBGP in the 2.3 task. The same iBGP need to be configured over here. Ensure that R23 and R24 learn the routes in the guest VRF VPN over iBGP. On R23 and 24, configure a static default route in the guest VRF and point it to the ISP's IP address 200.99.23.1 or 200.99.24.1 as appropriate. Advertise this default route in iBGP to VH21 and 22. On R23 and 24, configure PAT to allow the guest VPN to access internet by translating it to the router address on the link toward the ISP. Reuse the NAT ACL already created on the router. Do not use NAT tools. Basically, what they want that these interfaces must be configured with IP addresses, and these two should form iBGP and they should exchange the routes. That's it. Okay, and we need to configure PAT over here. Configuration on the router side. Just a second. So configure on the router and switch side. This is the configuration on the router side. Okay. VRF definition guest on R23. RD value is this, address family IPv4. On the gig 4 interface, we are forming VRF forwarding guest, IP NAT inside, and then we are giving an IP address 10.2.123.1/24. Then I'll come back to this loopback interface while we are configuring. Okay, this is the second part. Router BGP 65002 address family IPv4 VRF guest, advertising the default route. Then I'll come back to this. Then forming neighborship with VH21. Next stop self and activate the neighbor. I'll come to this DHCP part later on. Then we are creating over here IP NAT inside, sourceless NAT, interface gig 1, VRF guest, overload. Then IP route VRF guest, default route gig 1, and this is the outside interface IP address. And we are saying global. Same thing we are doing on R24, creating VRF guest, assigning IP to the interface and IP NAT inside. forming neighborship and advertising the default route under BGP and NATing. Okay. Now, if you see, there is a second part also. It says configure R23 as DHCP server for guest VPN according to these requirements. Create a loopback interface on R23 associated with the guest VRF and having the IP address 10.255.211/32. Advertise this prefix in BGP toward VH21. Create DHCP pool named BR1 guest for branch 1 guest subnet and DHCP pool BR2 underscore guest for branch 2 guest subnet. Explicitly associate both the DHCP pools with the VRF guest. In each subnet, assign addresses from .101 up to .254 inclusively and the appropriate gateway to the clients. Associate host 42 and 52 with the guest VN in the DNAC and make sure that both hosts receive their appropriate addresses. Make sure that host 42 and 52 can ping internet. Okay. So for that, what we are doing this configuration. We are creating a loopback 0, assigning it to the VRF. Then we are advertising that particular interface or that particular network under BGP. Then we are creating IP DHCP use VRF remote. Whenever you are configuring DHCP server under VRF, you have to use this. IP DHCP pool BR1 underscore guest, VRF guest. Network is 10.4.199.0. Default router is this. Excluded address is this. Then branch 2. Okay. So this is what on the router's side. So I'll just copy this. Go to R23. I'll paste this over here. Then I'll go to R24. Now we will go to vManage and we will create templates under vManage. So this time we have to go under templates and DC templates. So DC, edit, go to service VPN, add one service VPN. If you remember, we have created a service VPN 199. Now we need a BGP and interface. Now for BGP, I'll create a BGP template. And here I'll say BGP, DC, autonomous system. I am only running one autonomous over here, 65002. Unicast address family. I'll add a new redistribution. Add OMP. Add new neighbor. Neighbor IP will be device specific because I have two devices. Remote autonomous system will be 65002 global. Turn it on. IPv4. And don't forget to click on add. Then save. Now this is what interface template. So interface, this is not a sub interface. This is a physical interface. So remember, this is not a sub interface. Okay. Now here, as it is an interface, I'll say no shut. Interface name is GE0/2 on both the devices. And IPv4 address will be device specific because we have two devices. No need to change MTU as it is a physical interface. Save. Now these are the three things that we need to add over here. Update. Then this is VH21 edit 10.2.123.2/24 10.2.123.1 neighbor IP. update bh22 edit 10.2.224.2/24 10.2.224.1 update. Next, configure both the devices. Okay. Okay. Now go to DNA center. Now I forgot one thing in the previous task to assign IP addresses or to assign interfaces to particular VRF. So on branch 1, 41 will be under guest, sorry, employees. Or 41 was under what? 41 was under employee and 51 was under IoT. So 41 user device, address pool employee, update, save and apply. Assign. This is for 52 user device, guest, guest, update, save and apply. Same thing you have to do for branch 2. This is for IoT. And this is for guest. Save and apply. So this is what you need to do in task 2.5. Hope this is clear, guys. Any questions, anyone? We'll stop over here for today. We'll meet tomorrow. Okay. Thank you, guys. Bye. Take care. Tomorrow, 2.1 task. That is only remaining.